Hello everyone, this is Easy Automation here, and today let's have a look on the comparison instructions in Allen Bradley. Mainly there are seven types of comparison instructions in Allen Bradley, which are equal, not equal, less than, greater than, less than equal, and limit. In this video, we are going to learn how to use these seven types of comparison instructions in our program. Without wasting more time, let's begin. But before that, you need to like this video and subscribe if you want more videos like this one. Now let's begin. First we need to know what is comparison instruction. Comparison instructions are the PLC instructions which we use for comparing to constants or variables. Constants are the numbers which stay as it is throughout the program, and variables are the numbers which are going to vary throughout the program, like accumulators of counters and timers, or any kind of data registers like integers and floating numbers. And by comparing these values, we decide whether we want to start any output coil or any output instruction like timers and counters. Let's see how this comparison instruction looks. If we add any comparison instruction in our program, we will find that there is this source A and source B. What are these source A and source B? These are the simple values which we are going to compare by using this comparison instruction. Let's take an example of this equal instruction, in which if our source A and source B are equal, then the output instruction in this particular rung will operate. This is all about the source A and source B. Like, these are the values or data registers which we are going to compare, and by comparing these values we are going to decide whether our output should turn on or off. That's all about source A and source B. Now let's see how we actually use these comparison instructions in our program. For that we need to add one rung here, and we need to go in comparison instructions. Here you will find all the comparison instructions. For now I will just use this equal instruction here, and I will use one output coil here. Whenever our source A and source B gets equal, our output will turn on. And now I am going to add one another rung here, in which I am going to create one timer logic. For that I will add one NO contact here and one T on timer here. And I am going to give one binary bit address for this NO contact, and I am going to address this timer T4:0, and I'm going to set the preset value 20. Now what I'm going to do is I'm going to compare the accumulator value of this T on instruction with any kind of constant value like 1, 2, 3, 4. I'm going to put T4:0.acc in this source A, and in source B I'm going to put 8, and I'm going to address this output coil with one output address. Now if I start this timer and our accumulator value reaches the value 8, then only this output will turn on, otherwise this output will be off. Let's see how it works by running this program. Download, run. Now our program is in running condition, and if I toggle this binary bit, our timer will start, and whenever the accumulator value reaches the value 8, our output will turn on. Like, now our output has just turned on and off when our accumulator value was 8. This equal comparison instruction will only turn on this output coil whenever the values are equal. Like, whenever the accumulator value is at 8, then only the output coil is turned on, and this output coil will go off whenever the accumulator value is not equal to 8. This is how equal instruction works. Let's see the next comparison instruction which is not equal to. For that we need to go offline, and now I am going to add this not equal to instruction in our program, and now I am going to put the same accumulator address in our source A, and I am going to put value 7 in source B. Now whenever our accumulator value is not equal to 7, our output coil will turn on, and whenever the accumulator value goes to 7, our output will turn off. Let's see by downloading this program. Now our program is in running condition, and now you can see that our output is turned on because our accumulator value is not equal to 7, and whenever our timer accumulator value gets equal to 7, our output coil will turn off and will turn on again, because our timer is not going to stop at 7. It can accumulate values beyond 7 because our preset value is 20. That's why our output coil will turn off and will turn on again. Let's see how it works by running this timer. For that I need to toggle this bit, and our timer has started, and whenever the accumulator value reaches 7, our output coil will turn off and will turn on again, because our timer accumulator value is rising towards 20. So this is how not equal to works. Like whenever the accumulator value is equal to 7, our output coil will turn off, and whenever the accumulator value is not equal to 7, our output coil will turn on. So that is all about the not equal to comparison instruction. And now let's see the next comparison instruction, which is less than. So for that we need to go offline. So now I will just replace this not equal to with less than. So for that we need to put LES, enter, and that's how I have replaced the not equal to with less than. So now whenever the accumulator value is less than 7, our output will turn on, and whenever the accumulator value goes beyond 7, our output coil will turn off. So let's see by running this program. Run. So now our program is in running condition and our accumulator value is at 0. So that's why our output coil is turned on here, because 0 is less than 7. And now if I toggle this binary bit, our timer will start and our accumulator value is rising, and whenever the accumulator value goes beyond 7, our output coil will turn off, and it will only turn on whenever the accumulator value is less than 7. So if I untoggle this binary bit, our timer will reset, by which our accumulator value will go to 0, and 0 is less than 7, so that's why our output coil will turn on again. So this is how less than works. And now let's see the next comparison instruction, which is greater than. So for that we need to go offline, and I will just replace this less than with greater than. So for that I need to put GRT, enter, and this is how I have replaced the less than with greater than. So to test it, I will download this program. So now our program is in running condition and we are using the greater than instruction. So that's why whenever our timer accumulator value goes beyond 7, our output coil will turn on. So let's see how greater than works by toggling this binary bit. So toggle, and our timer is started and our accumulator value is rising, and whenever the accumulator value goes beyond 7, our output coil will turn on, and it will stay turned on until the timer accumulator value goes below 7. So for that we need to untoggle this binary bit, by which our accumulator value will go to 0 and our output will turn off. So this is all about the greater than instruction. So now let's see the next comparison instruction, which is less than equal to. So for that we need to go offline, and now I am going to replace this greater than with less than equal to. So for that we need to put LEQ, enter. So I have replaced the greater than with less than equal to. So let's see how it works. So for that I will just download this program and run. So now our program is in running condition and our output is on because our accumulator value is at 0, which is less than 7. So this output coil will turn off whenever the accumulator value goes beyond 7. Like whenever the accumulator value is at 8 or beyond 8. So let's see by toggling this binary bit. So toggle, and our timer has started and our accumulator value is rising, and whenever the accumulator value goes to 8, our output will turn off and it will stay turned off until the accumulator value goes less than 7 or equal to 7. So for that I will just untoggle this binary bit, and our accumulator value has gone to 0 and our output is turned on because our accumulator value is less than 7. So this output coil will turn on whenever the accumulator value is between 0 to 7, and if accumulator value goes beyond 7, our output coil will turn off. So that is all about the less than or equal to. So let's see the next comparison instruction, which is greater than or equal to. So for that we need to go offline, and I will just replace this less than equal to with greater than equal to. So for that I will just put GEQ, enter, and to test it I will just download this program and run. So now our program is in running condition and our output is off because our accumulator value is at 0 and it is not equal to 7 or greater than 7. So that's why our output coil is off. So to turn it on we need to increase the accumulator value, and for that we need to toggle this binary bit, by which our timer will start and our accumulator value is rising. So whenever the accumulator value reaches 7, our output coil will turn on and will stay turned on because our accumulator value is rising and it is greater than 7. So whenever our accumulator value reaches 7, our output will turn on and will only turn off whenever the accumulator value is less than 7. Like whenever our accumulator value is between 0 to 6, our output coil will stay turned off, and whenever the accumulator value reaches 7 or goes beyond 7, our output coil will turn on. So to turn it off, I will just untoggle this binary bit by which our timer will reset and our accumulator value will go to 0, and 0 is less than 7, so that's why our output will turn off. So this is how greater than or equal to works. And now let's move further to our last comparison instruction, which is limit, and it looks different than other 6 comparison instructions. So to use it, we need to go offline, and now I am going to add this limit instruction in our program, and this is how it looks. Like it has no source A and source B like the other ones, but it has low limit, high limit and test. So what does that mean? Test is the value which we are going to compare with low limit and high limit. So here I will just put this accumulator value, and I will set the lower limit to 8 and higher limit to 15. So here I have set the lower limit and higher limit. So whenever our accumulator value is in between the 8 and 15, our output coil will turn on. So let's see by running this program. But before that, I will just delete this greater than equal to instruction, and I will just download this program and run. So now our program is in running condition and our accumulator value is at 0 and our output is not turned on because our accumulator value is at 0, which is not in between 8 and 15. So to turn on our output, we need to increase the accumulator value by toggling this binary bit. So I will just toggle this binary bit by which our accumulator value is rising, and whenever the accumulator value is in between 8 and 15, our output will turn on, and it will turn off whenever the value goes beyond 15. Like now, if value goes beyond 15, our output will turn off and will stay turned off until the accumulator value goes between 8 to 15. So if I untoggle our binary bit, our timer will reset and our accumulator value will go to 0, and if I toggle this binary bit again, our timer will start and our accumulator value will rise again and it will reach 8, by which our output coil will turn on and it will stay turned on until the accumulator value reaches 15, and whenever it goes 15, our output coil will turn off and it will stay turned off until the accumulator value comes in the range of 8 to 15. So this is how limit instruction works. Like it will compare the accumulator value with lower limit and higher limit, and if the accumulator value is in between the lower and upper limit, then our output will turn on. So that is all about all the comparison instructions in Allen Bradley. I hope you got the idea how to use them in your program, and if you learned something new today, make sure you hit that like button, subscribe if you are interested in PLC programming, and share this video to your friends and colleagues who are interested in PLC programming. Comment down all the thoughts and queries in your mind. I will always be there to answer your queries. So with that being said, I will see you in the next video. Till then, keep exploring our previous videos where I have talked about the program control instructions. So see you again. Bye.